I'm here today with Nick Marchmont, and we're going to be talking about sacred geometry. Hi Nick, and thanks for joining us today.
Hi, great.
So I looked at my dictionary this morning, and geometry, it's the branch of mathematics concerned with the properties, relationships and measurements of points, lines, curves and surfaces. Now it mentioned analytical geometry and solid geometry as two specific areas of geometry, but there was no mention of sacred geometry in the dictionary. No mention at all.
Well, that of course was my first problem in putting the talk together, because my main aim in doing the talk is to get people enthusiastic and interested in something that people have already scared them away from. And the way they were scared away was by using language like that. The geometry is actually easy because it's a reflection of number. Number is a product of mind, all the maths we do in our head. Geometry is an expression of number in space. So geometry is the way number fills space, and we're going to see all the forms that do that. It's the sacred bit that is especially difficult though. I think because people, excuse me, people are put off by the word sacred, and that is another word which, if you look it up in the dictionary, it doesn't have a very satisfactory definition, or one that's useful at all. So I was forced to define it for myself, really, and I define the sacred as that which remains constant through time. We know that most information doesn't. In Shakespeare's time, in Elizabethan England, they thought that the world was 6,000 years old, that it was created in 4004 BC. We now know that the world is 6,500 million years old, or 4,500 million, which is a big difference. The same happens with the religions. They change over time. You get a kind of the New Testament is a new version of the Old Testament, which itself is kind of constantly revised. Well, this geometric information has remained unchanged since it was first written down by Euclid about 300 BC. So we've learned more about it, but the fundamental principles, which is what this talks about, has remained unchanged for 2,500 years.
At least, yeah.
At least.
Yeah,
well, Euclid was the first one to write it down in languages that we know about. In fact, if you look back, we can see that the Babylonians had very advanced geometry. They had the use of the number 0, which is gives you the ability to do technical maths and difficult geometry. And even before them, the Sumerians probably knew about this as well. And they would have written it down as well, but they wrote it down in thousands and thousands and thousands of cuneiform tablets, which we're still busy translating. And before them even, we see in the talk, we see a set of platonic solids, these solid geometric shapes that were made by some New Stone Age people. The New Stone Age is characterised by the appearance of polished tools, so really nice polished axes and sickles, not just the rudimentary stuff, with burials, and with the start of settled life. That's basically how they define the New Stone Age, the Neolithic. And we know that New Stone Age people, the same people that built Stonehenge, were carving these shapes out of stone.
So in other words, I mean, most people watching this hopefully will be aware of the fact that most of the official history books that we now have are pretty much a work of fiction, and ever more so, some people would say. And that the education system in this country is arguably more interested in kind of propaganda and conditioning than it ever is in education. That's a controversial view, but what you're saying is then the history of this is just one of the many things that has to keep continuously be revised due to new information.
I think so. It's not so true of this particular subject. The problem with this subject is all the information was just hidden.
It was hidden. That's what I meant. Not changed. It stayed the same. It stayed the same. But
it's sort of resurfaced. Is what's happened. Yeah.
In terms of say Pythagoras, if people say Pythagoras discovered or was the first person to use this thing, but then we find examples far before that, don't we?
Yeah.
Yeah.
But that's down to the development of writing. I think we developed writing partly because we were starting to forget things. Our narrative culture was disappearing. Also, of course, when you deal in an oral culture where people are telling you stories, the story is constantly being suited to the audience. which means that everything is unique and textured to the place where it's being told and the people that are listening. Once things started getting a bit complicated, once we developed cities especially, and temples came first, then cities, then the mercantile class, then writing. So writing is a means of control, because one of the things it does is it makes the record uniform. It means it's not different for this person over here from what it is over there. And starting to write things down means that your ideas are preserved. Obviously, in the archaeological record, we can find as many bones and buildings as we like, but it tells us absolutely nothing about what was going on in the heads of the people. Once they're writing stuff down, we understand. Now, that's why Pythagoras, although he's known for a lot of arithmetic proofs and stuff, is not necessarily regularly connected with the geometry we're talking about here, because he didn't write his thoughts down. Plato, who's one of Pythagoras' students, did. And as a result, these forms tend to be referred to as Platonic forms. You mentioned the two different forms of geometry, the analytic and the solid.
Yeah.
We're not dealing with the analytic, we're only dealing with the analytic indirectly. Solid geometry is the forms we're looking at, as I say, the way number actually occupies space. Analytic geometry was a Cartesian idea, René Descartes. He discovered that you could actually plot this geometry onto a flat graph using an x-axis and a y-axis. You've got 4 quadrants, and that meant, because these are 3-dimensional objects, you could describe them. Once you can describe them on that kind of grid, you can then do arithmetic with them, which takes us into the bit that we don't deal with, which is number.
So in other words, sacred geometry, it's something that remains constant through time.
Yeah.
Even though the history of it is sort of debatable, we've found things far in advance, and it's a way of representing number in space.
That's right.
Yeah.
The other important thing is that it's been used in all of the sacred spaces that we use. These basic fundamental geometric forms are used for designing stone circles, barrows, and churches, even churches. Also, they lie at the root of the whole natural world. Absolutely everything is governed by these really simple geometric rules, and that's everything from the cells that make up your body, your kind of endocrine system, all of that, right the way out to galaxies. They are the same simple rules reflected upon themselves and again and again and again, and they just literally stack up. So
in other words, we talk about history, but really geometry's been there since the beginning. It is the building blocks of everything.
It absolutely is. It absolutely is, because right down on the kind of on the molecular or on the atomic level, what makes a difference between one of the elements and another is purely and simply the number of protons in its nucleus. So hydrogen's got 1, helium's got 2, the next one, which I think it's lithium's got 3, and they just build up. So all the elements we've got, it's just by adding 1 more proton to their nucleus, and that's a geometric progression. 1, 2, 3, 4. It's slightly more complicated than that, but it's not part of this subject really.
And you talk about all the sacred sites and everything have this kind of same. I mean, I suppose everything has this geometry. Everything in nature has this.
That's right.
This geometry, and as everything it ultimately comes from nature. Now, a lot of these sacred sites in this country, people have said, are linked in a geometrical way. In terms of their position in the country. Is that something that you're familiar with, that idea you're familiar with? Or?
I definitely am, yes, and it's something that, since I started doing this talk, materials are synchronistically arriving with me, and one of the subjects that I'm starting to look at is, there's lots and lots of this stuff, again, from ancient times. There's tales that the whole of the UK can be divided up into right-angled triangles, that Edinburgh, London and Cardiff are in exactly precise correlation with each other geometrically, and that you can then scale that down and find it applying to lots of other important centres. I find all of this absolutely fascinating. There's a chap I'm meeting later this year who's done a detailed geometric map of Llangollen, and apparently he's found some really exciting stuff. I had a quick look at it, and it does look fascinating. So I think there's definitely geometries in the landscape, but that, you see, one of the feelings I have is that there's a message somehow that's coming through to us from a long, long time ago. It might be from Atlantis, it might be from Lemuria, it might be from an invading alien race, but from somewhere there's this feeling that we've been moving towards a point and that we're being guided to it. It's like, I mean, the best way I can illustrate it is, you know, we've got all these fantastic big temples around the place, like, say, Stonehenge, which was sort of built 3,200, 3,500 BC. Well, as we've kind of moved towards the present day, big temples, large structures that are massive, related to the size of the earth and stuff, have been built in each millennium. So that, I mean, the most recent one was probably Angkor Wat in Cambodia, which is absolutely gigantic. Even as they've discovered it, it's got 4-mile long causeways and giant rows of kind of demons churning the Milky Way and all that sort of stuff. But that was 1000 AD, and yet even there, the guy that built it kind of went round and surveyed the site. He built capital cities in 4 or 5 places before deciding where to put his temple. And just recently, I guess because of Google satellites and stuff, they've actually discovered that Angkor Wat is even bigger than they thought it was. They've found El Dorado, they reckon, now in South America. Loads of really, really straight lines meeting each other, which is a sure sign of human involvement, because nature doesn't do the straight line thing. So it's almost like there's a consciousness working through us, building all of these places exactly where they need to be. Melchizedek makes a point that things like Easter Island is on 72 degrees removed from another important site, which I can't remember where it is. But of course Easter Island would have to be exactly where it is to pull that stunt off. So
the island itself, then?
Yeah, because if you need it to be 72 degrees away from, say, Giza, I think the whole thing's based on the Giza Plateau, that particular plan. But that's a 72 degrees all the way around the Earth. You'd have 5 of those sites, and one of them really needs to be where Easter Island is, and Easter Island just happens to be there to take it. So I'm wondering what scale of plan we're looking at.
So it's amazing, yeah. I mean, it's quite a claim to say that, but I mean, it's quite a bigger plan then.
Loads of different
something that we're not quite aware of at the moment. It's maybe a learning process for us all the time.
Well, the more you hear about you've got to connect it all in, haven't you? The stuff you hear about, you can't really regard it as irrelevant. So one of the things I had a passing interest in as all of this developed is the state of our solar system, especially Mars, which is, as I know, one of our favourite subjects. And there's a lot of emphasis on the face on Mars, which turns out it appears that it's a naturally eroded hill. Still a very interesting one, and it looks like it's been worked before it got eroded. So the European Space Agency took a photograph of it, which they said shows that it's a natural formation. Well, for a start, I don't necessarily swallow that. It might be true. But what I think's going on there is that by concentrating on the face, they're distracting us from some really, really important work that was done, where a piece of American military software was run over a load of dots. There's the face, there's a 5-sided pyramid, and the 5-sided pyramid itself is an extremely rare form, a difficult form of the Pentagon. And there's several other really interesting features there, but beyond it, there's a load of like mounds. And the American software that was run over it was designed to discover camouflaged gear. So what it's looking for is straight lines within the fractal, because nature's entirely fractal. Anything that goes non-fractal is manufactured. And if you look in detail at the arithmetic that came out of all these lines, it expresses, I can't remember what the number is, but I think it's dozens of really important equations, like 2 pi r, pi r over 4, constantly turns up the tetrahedral constant, 19.5 degrees. And these all come out as results of relationships between the lines that this computer program draws between the mounds. Okay?
So basically people are building things on Mars then?
In the past they have done. The conclusion of the people running the software is it does its job really well, and if you've got something that is not fractal, which that isn't, then you've got something that was manufactured.
Right. So this is the other thing then. We talk about geometry in nature, but anything that's man-made doesn't have this geometry then. That's
it's different. It's really, our geometry is really, really regular.
Yeah.
When you look out across the countryside, all of the straight lines would be made by humans.
Yeah.
There isn't actually anything that straight. And because geometry governs the growth of everything, you're effectively dealing with a fractal appearance, a bit like a fern. You know how a fern leaf, as it unfurls, it's in a particular spiral. And all of the little edgy bits off it are like very mini versions of the big leaf. and the plant itself
like
is
a
like
hologram sort of thing.
exactly right.
Yeah.
So that's how nature does things. We don't build things fractally.
Yeah.
If we did, our buildings would look a lot better, I think. You know, you look at some of the Chinese temples and stuff, they've got a kind of fractal appearance to them, in that each bit's a little smaller than above, but by and large, we don't build. It's not the geometry that's the problem with the Martian stuff, it's the equations. It's the fact that these particular triangles or particular expressions are very complex, basic arithmetic facts about the way things are built. And the chances of them, the mounds just arriving like that, are practically zero. That's the thing, is the chances of a load of random mounds appearing on a planet that express all of these different things. They'd say, the people who are running the software would say effectively that's a camouflage lorry.
Okay, so we've got that with basically there could have been a civilization on Mars. People are saying there's things going on Mars at the moment. Let's just go to let's go back to sacred geometry just for now, so we can keep on this subject. Now, we're just talking about nature. I've spoken to pagans before, and they have said that nature is chaotic. That seems to be a view of some pagans, that it's chaotic. What would you say to that? Because nature is symmetry. From this argument,
it's I think it's probably a misdefinition or a misuse of the word chaos. Because nowadays chaos has a pretty technical meaning because of chaos theory, and chaos by and large is a level of order that we don't yet understand. So pagans who say that nature is chaotic don't necessarily understand the golden rules that kind of underpin the whole thing, so that each leaf will come out on the stem to gather the most amount of sunlight it can, taking into account all the other leaves, and the particular rule that makes those leaves come out in a specific place also does everything else, because it's the law of growth and proportion. So, for example, this bit of my finger, this little bit here, is 0.618 of that bit. So this is 1.618 of that, and then this is 1.618 of that. This is 1.618 of that. And it just goes on and on. It's the same proportion right the way up through your body. It's the same for frogs, it's the same for fish, same for those.
For all animals then?
Really, and all growth, all organic growth is done on those principles.
So it's the same ratio? So these people say that it's just a genetic accident, that humans, crawled out the swamp or whatever, rather than being created. It's more likely that they were created using these patterns then, would you say? Or it's a big question, isn't it? But.
It is a difficult question, but yes, there are one of the points of the geometry talk is that that we're looking at complexity that's generated from really, really simple basis, just repeated again and again and reflected.
So what you're saying is it's quite simple then. It's just a simple. What was the thing? I can never remember the figure, but
the 1.618. It's called
1.618, and then it goes down like you say.
That's right. And the matchbox, the Swan Vestas matchbox, is the same proportion. It's called the golden proportion. And I'm not going to go into the arithmetic, but it's a very, very specific cut of a line. And when you see a spiral growing in an ammonite or a snail, that's doing it as well. So although it looks chaotic...
This is the Fibonacci spiral.
That's it, That's right, it is a Fibonacci spiral. I will put one on the... seeing as we're talking about one, I'll put one on here so that people can see what we're looking at. I put that there. That's a Fibonacci spiral, and you can see that it looks like a snail shell or a nautilus. Well, it's exactly that spiral that governs.
So just point us through which bits gets bigger and everything.
Okay, it's here we go. What you've got, the Fibonacci series is a series of numbers that approximate to the golden mean, and the way it starts is you start with a square in the middle, which is measured 1 by 1. Okay, if you add 1 and 1 together, you get 2. So what you then get is this little rectangle in here, which is 2 by 1. Okay. So now if you add 1 and 2, you get 3, and this next square is 3 by 2. Okay. And if you add 3 and 2 together, you get 5. So the next square is 5 times 3. So it's going up. Now the thing is that as these numbers get bigger, 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. 21 plus 13. So you can see they're getting bigger and bigger, but they're in pairs. Now if you take the largest of the number and put the smallest number, divide the smallest number into it, get 1.6180339. Now the bigger the numbers get, the closer you get to the proper value of phi.
Yeah.
But that proper value is like the value for pi, it's an infinite number.
Yeah.
It goes on forever after the decimal point
Yeah.
without ever repeating itself. So the higher the Fibonacci numbers, the closer you are to getting a definitive answer to phi, okay?
Right.
So that's a really, really interesting thing. There's a couple
Yeah.
of other important things like phi squared plus phi cubed equals phi to the power 4. So it's doing really complicated maths, volume maths, by just adding one number to another,
Yeah.
okay?
Yeah.
But the most amazing thing about it is you look into the centre of a sunflower and what you see is a pair of spirals running in opposition to each other. Those spirals will have Fibonacci numbers of seeds in them. So
Right,
one
yeah.
will have
Yeah.
13 and the other will have 8, say.
Right, I
And
see, yeah.
it's nature's most effective packing system.